Yeah.
Okay, so we're gonna start it. Because the very first thing we're gonna talk about is pretty important. So I want to make sure Lily, Rika, you guys are still there. Okay. Then so Aaron, I'm just looking at your homework. I believe you basically understood 10.4 because you did R times S, R plus S, that's correct. Yeah, not bad. Okay, so let's because last time we only talked about until like 10.3, so we're gonna start with 10.4. Okay, so before 10.3 it's just about quadratic factoring stuff. I think so later Rika should be fine. Is there any problem for anything before 10.3? Lily, do you have any problem for the factoring? No? Okay, good. So let's talk about 10.4, sum and products of roots of a quadratic. So Lily, have you learned about this in your whatever like practice you've done, like Excel? I don't know. 你课外的数学你有学过这个吗？ Sum and roots, sum and products of roots of a quadratic. 你有学过吗，Lily？人呢？Rika 应该没学过吧？
这种是就是那个就是
就是
x 方减去 something，然后减去加上或者减去一个
对，这个是
constant 吗？
对，那个是 factoring。这个呢，我们说的是就是一个 quadratic 不是有两个解吗？一个二次方程，两个解的和还有两个解的积，有学过吗？
应该没有。
没有是吧？OK，我们来把它 go over 一下。So for this, there were some questions here, but I believe that we don't have to go over these questions. I can just prove this for you guys, okay? Just prove this to you guys. So I'm just gonna go over this problem and see if you can understand, okay? I believe Aaron has understood. So Rika and Lily, just see if you two guys can understand, okay? If you don't understand, make sure you let me know. I'm gonna first explain it. If you understand, that'll be the best. Okay, then that's basically it. So suppose R and S are the roots of a general quadratic, and then we're gonna prove that the product of roots is C over A, and the sum of roots is negative B over A. 这里的这个Rika，包括 Lily 看一下，这里的它这个 conclusion 呢，就是说，如果一个 quadratic 有两个解是 R 跟 S 的话，那么它们的和就一定是负的 B 除以 A。B 和 A 是什么？就是这里两个数啊 ，ax 方加 bx， 负的 linear coefficient divided by the leading coefficient, negative linear coefficient divided by the leading coefficient. Okay, and then the product of roots 就是两个根的积啊，两个根乘起来会等于谁呢？会等于 c 除以 a， 或等于后面这个 constant divided by the leading coefficient. Okay, so this is a claim, this is a statement, and we want to prove it. So Aaron, I believe you have understood. Do you know how to prove this? I know you're using it. You're using it in your homework. But
am I? Oh, am I? I'm not sure.
You're not sure? Okay, I saw that you're using it in your homework, like RS.
Yeah.
Did that homework, yeah. So, but you don't know how.
What does roots mean in this context?
Roots just means solutions. Yeah, roots, solutions, they are the same, they're synonyms, okay? So so in Mandarin we say 根解和根啊 solutions 就是翻译成解 OK 解嘛 and then roots 我翻译成根 right 解跟根they're the same. They mean the value of x that will make this equation true, that will make this equation equal to 0. Okay, so roots are the values of x that will make this equation 0. Okay, make sense? Yeah, okay, good. So how do we prove this thing? Then ax squared, maybe I'm gonna do an example first, and then before we do this, we'll do an example with numbers, and then we do letters, okay? two numbers and with letters. Maybe let's do this. Just do a harder one, okay? So consider this equation, 5x squared plus 59x minus 12 equals 0, okay? Now, if we consider this equation, what are the roots? How do we find the roots? How do we find the solutions? We use quadratic factoring, right? Can anyone give me the factors of this quadratic equation? So Aaron, do you remember what we learned that last time? We set up numbers and stuff? Yeah. Okay, I'm gonna do it as well. So Lily can also do it. Shouldn't be too hard because there's 59. Okay, so Aaron, see if this is the thing you found. And Lily. Okay. So the middle, the linear coefficient is 59, which is a pretty big number compared to 5 and 12, right? We know that 5 times 12 is 60. So we can immediately know that we do 5 and 12 as a pair, and then 1 and -1, right? So that we get 59. So 5 times 12, 60, minus 1 is 59. Then we get the middle, the linear coefficient. Okay, everyone, that makes sense to you? Do you remember this?
Yeah. So does this mean that all but -1 are the roots?
No. This means that we are factoring out the quadratic equation. And after we factor it out, we let each bracket equal 0 and then find the solutions or the roots.
Oh, so solutions are the roots. Okay.
Yeah, I'm going to show you, and I think you will recall, okay? So
But then
what?
in 1023, it says that R and S are the roots, but then in the product in A, it says that it's the number that's being subtracted.
A is being subtracted. Okay, just put this aside for now, okay? Put that aside, because that's letters, okay? Those are letters. So what these numbers mean is that, well, 1 and 5 are, well, they are leading coefficient. So they are actually just 1x and 5x, right? And then for 12 and 1, they are just constant numbers, okay? So we set up brackets, and so that we know the two factors of this quadratic equation is x plus 12, and then 5x minus 1, correct? Okay, so Lily, that makes sense? And then when we try to solve for this equation, then we're just gonna make each factor equal 0, right? Because it's two numbers, they multiply each other, you get 0, so it's gonna either be the first bracket being 0 or the second bracket being 0. log 呢 ？OK， 瑞卡，你这个那 log 呢啥意思啊？瑞卡，
就是我也不知道他们那个叫什么 log 在那个左下角那个。
log 在下角 ，log log 我这还没到，没学到 log，OK 吧？
啊，不是 log 吗？
哪个是 log 啊
就是你说那个 root。
？root， 哦 root 不是 log，OK， root 不是
OK， 好。
root 就是根，就是解，就是让这个 function 啊，让这个 equation 是正确的，这些 x values 就是哪些 x 值可以让我们现在的这个 equation 呢是对的，这个就叫做 root， 这个就叫做 solutions。log 是完全另外一个东西啊 ，log 是以后我们才会学的，像我刚上的那门课。
Taught us a bit about log before.
Yeah, okay, yeah, we talked a little bit about log before, yeah, but it's totally different, okay? Log is different. Log is in school curriculum, that's math 12, okay? We're gonna learn about it much later, okay? And in AMC, log is in AMC 12. So for AMC 10, we won't study it, okay? Yeah, but anyway, so we have two factors. So everyone remember each factor being 0, right? So the first solution is x is -12. And the second solution is, well, 5x minus 1 is 0. So 1/5. right? Okay, so these are the two roots. We can, now what if we find the sum of roots and then the product of roots? We can have a look, right? So the sum of roots is negative 12 plus 1 over 5. And that's negative 60 over 5 plus it, so negative 59 over 5, right? Notice that it is just, negative 59 over 5 is just a ratio between the linear coefficient and the leading coefficient. So in other words, this is negative b over a, sum of roots. Okay, and then if you find a product of roots, negative 12 times 1 over 5 is going to be negative 12 over 5, and that's just going to be c over a. You see, negative 12 is c, and a is 5, right? C over a. Okay, so sum of roots is negative b over a, product of roots is c over a. We can see this in any quadratic equation. And then we get to prove it. Okay, so to prove it is not that hard. Basically, for this, because the reason why we can get two roots is because of the two factors of the quadratic, right? So say that we know the two roots, then we can set up the two factors, and then if we multiply the factors out, we should be able to get the original equation. Okay, so Aaron, that should make sense to you? Okay, so Ricky, see if that makes sense to you. The logic, 好吧？你们看啊，如果我们知道这个两个 root 的话，两个根，如果两个根已经知道了，我们是不是可以回去把这个 factors 给找到啊？因为每一个根都是来自于 factors 嘛，对不对？如果把 factor 找到之后呢，你这个 factor 乘出来就应该是给到我们原来的这个 equation。我们可以通过这个方法来证明底下的这个 claim。好吧，如果感觉没问题的话呢，我们来看一下怎么证啊。那么就是底下这道题了。All right， 我们来看啊。So for a general quadratic equation, ax squared plus bx plus c equals 0. Because it's general, we don't actually know their roots, right? So we have to suppose their roots. Correct, everyone? Aaron, right? So we suppose their roots to be r and s. So usually we suppose root to be r because, well, r is the first letter of the root of the word root, right? But we have two roots, so that's why we do r and s, because it's alphabetical letter, alphabetical order. Okay, r, s. If we have three roots, we use r, s, t. If we have four roots, we use r, s, t, u, etc., etc. Okay, makes sense? It's a conventional notation for root. Okay, we always suppose root to be r, and then s, and then t stuff. Okay, so if we have if we have r and s being the roots, then what are the two factors that will give us these two roots? What are the factors that will give us these two roots? Then that will be question A, right? X minus r and x minus s. So think about this. If you have x minus r times x minus s equals 0, isn't the case that x is going to be r and s? So the roots are r and s. Right? Make sense? In other words, say the two roots are 1 and 2. Then that means your factors must be x minus 1 and x minus 2, right? If your two roots are negative 1 and 0, that means your two factors must be x times x plus 1. When x is 0 and x plus 1 gives you the root of negative 1. If your root is, say, 1/5, and then 8 out of, I don't know, negative 8 over 3. And that means your factors must be, well, the first one must be x minus 1/5. Second one must be 1 plus x plus 8/3. Well, everything should be equal to 0, of course. Does that make sense? So Aaron, that makes sense? Yeah. Rika, Lily, does that make sense? Based on the roots, we can go back and then know the original equation. How do we know it? We first set up the two factors, right? Based on the roots, we set up the two factors and make it equal to 0. And if you want to get back to, well, if you want to simplify, just open up brackets and that's it. Okay, Lily, make sense? Lily, I haven't heard you from, can you open a camera, please, Lily? Okay, thank you. Yeah, so Lily, does that make sense? This is, if you're not, I know. Okay, good, good. Okay, so yeah, that's basically what question A is saying. So we suppose that the quadratic have two roots. Okay, I'm gonna turn on my camera as well. Okay, Rika. Okay, Rika, go. Okay, so Rika needs a few minutes to go back home. All right, but I'm gonna explain this again, and then when Rika comes, I'm gonna explain yet again. Okay, so that you have 2 times to to understand this, because this is very important. So we know that if I'm gonna write it down here. Oops. So if the roots are R and S, we suppose the roots are R and S, right? Then we will have the following equation, okay? And remember that we suppose the roots of what are R and S? We suppose the roots of a general quadratic equation are R and S, right? So that means this equation, ax squared plus bx plus c, should be equivalent to this equation. Is that correct? Right? Because both of them give you the same roots, right? If both equations give you the same roots, then they are the same equations, at least equivalent equations. Okay, did that make sense? So we can just make them equal, right? They're exactly two same equations because their roots are the same. That's the logic behind this. Okay, if that makes sense, then we can just make them equal. Ax squared plus bx plus c equals x minus r, x minus s, and both equal to 0. Correct? There is just a tiny slight problem here. If you compare between x times x and then ax squared, there's a little problem, right? Because in the second part, in 2 factors here, x times x, you only have x squared. But for this original equation, you have a times x squared. So how do we address this a?
1.
Yeah, we can make it equal to 1, but what if a is not 1? Then we can just simply time by a. Because if you time it by a, it equals to 0, right? If you time by a here, it doesn't really affect your roots. Even if you have a, whatever number it is, can be 1, can be 2, can be 3, can be -2, can be 1/2. It doesn't really affect the fact that this equation, a times x minus r, x minus s, having the roots r and s. Does that make sense? Right, Lily, does that make sense? So the reason why we want to time by an a here is just to match, well, ax squared, to match the leading coefficient. The roots don't change. So this basically means that, for example, if our roots are 1/5 and -8/3, we said that this can be one of the possible equation. But you can also have other equations. Say that you time by 5, and you time the 5 in. That means you the first factor becomes 5x minus 1. The second factor is still x plus 8/3 equals 0. You see, this equation also have these 2 roots, right? So knowing the 2 roots, you don't actually know exactly what your equation is, but you know what your factors are. And these 2 factors can multiply by any other number to produce some possible other factors. Okay, you can also time it by 3 again, so that you can change this to 3x plus 8. Doesn't matter. 3x plus 8 will give you this solution. Okay, hope that makes sense. So that's why we time by an a to match the leading coefficient. Or like Aaron said, you can change it to 1, right? If you want to change it to 1, basically just you can divide this by a, so that it becomes x squared plus b over ax plus c over a. This is fine as well, right? Because if you divide by a, the other side is 0, it doesn't really change anything. So both are fine. Okay, you can do anything. One. Let's just say we divide by a then. Yeah. So okay. Because both will give you the same result. Let me delete this, and then for this, I'm gonna do a little bit manipulation to it. No, let's divide it by a so that we get x squared plus b over ax plus c over a equals to 0. Okay, it doesn't change the solution or the roots of this equation, or this equation or this equation. Okay, so in the end, that means, well, this equation, this factored form of the equation equals to this equation. They're equal, right? Okay. Now, since they're equal, we can just open up the brackets and see what the relationship what's the relation we have for R and S, and then B over A, C over A and stuff, right? You're seeing what a claim or what a claim stated before, right? So here we can open up brackets. It becomes x squared, and then times this minus Rx times this minus XX, and then times this, so plus RS, right? So just open up brackets, and the left-hand side is the same. Okay, make sense? Yeah. Okay, if that makes sense, and then on the right-hand side, we can combine like terms, right? So we have x squared, and then minus Rx minus XX, that's, well, those are like terms. So if we combine them, that's minus R plus S bracket X, right? Okay, and and lastly we have plus RS. And again, the left-hand side is still the same. What do we have next? You see that x squared, they cancel? Okay, and then if you look at the second term is a linear term, remember? The linear term. So, wait 1 second. Okay, Rika's coming. Rick, hello, Rika.
Hello，
Hello， 你能开下 camera 吗？
可以。
好 ，OK， 我现在是讲到这里了，待会儿再给你再讲一遍，好吧？因为这地方很重要，我等会给你再过一遍啊。那你可以先听着啊。Okay, so we open up brackets, and then notice that this is a linear term on the left-hand side, right? So let's write it down. Let's compare the linear term of the left-hand side. The left-hand side is b over ax. The linear term of the right-hand side is minus r plus s x, right? Since the left-hand side equals the right-hand side, then of course the linear term of the left-hand side must be equal to the linear term of the right-hand side, because there's only one linear term on the left-hand side, and then there's only a single linear term on the right-hand side. They must be the same. They must be equivalent to each other. Okay, so everybody, does that make sense? 对吧? So left-hand side equals to right-hand side, then the linear terms must be equal. Otherwise, if they're not equal, then if x changes its value, they're not equal, right? They must be equal. Say that on the left-hand side you have 3x, then on the right-hand side you must have 3x as well, so that it can be equal. Okay, it can always be equal. If that makes sense, then here comes our conclusion. So we can actually cancel out the x, right? And then eventually we have r plus s, which is the sum of roots, equals, we move the negative sign to the other side, negative b over a. And that's it, right? The sum of roots equals negative b over a. Does that make sense to you guys, Aaron, Lily? Okay. And then for the product roots, they'll be here, right? R times s, and that's this. So if we compare the constants, linear terms, so if we compare the constants, on the left-hand side is c over a, on the right-hand side is r times s. And there's nothing you need to do. Just say RS equals C over A. Right? It's literally just RS equals C over A. Okay, done. And these are the two claims that we are trying to prove. Okay, see if that makes sense to you guys. Okay, I'm gonna go over this again, using Mandarin and Rika can have a look. OK， 你看啊，我们现在要证明一个什么事呢？Rika 刚刚你应该都看到了，我们这边有一个 example， 对吧？就是说啊，你一个 quadratic 不是有两个 solution， 两个 roots 嘛，对不对？两个根，这两个根相加呢，就刚好是负 b 除以 a。b 是什么 ？b 就是这个linear coefficient x 前面的系数 ，OK 吧 ？a 呢 ，a 就是 leading coefficient。你看这个是不是在这里可以看得出来这个例子里面，对吧 ？OK， 那么如果是两个根相乘呢，叫做两根之积哈，我们中文说两根之积，两个这个 products 好吧？那么 products 呢，它就刚好是 c over a 相乘，两个根乘起来是 c over a，c 是什么 ？c 是 constant， 然后 a 呢 ，a 还是 leading coefficient， 因为我们这边的 a、b、c 全部都是这个 general quadratic equation 里面的 a、b、c。就分别是 leading coefficient, linear coefficient, and a constant. Or you could say constant coefficient. OK， 没问题吧？那么，所以我们要证明一个事情，证明什么事情呢？就是这个叫做 r plus s 两根之和啊 ，sum of roots 是负 b 除以 a， 而 r times s 是 c 除以 a。那我们怎么证明呢？我们就看啊，我们先假设一个 general quadratic， 对吧？这么一个方程。它的 roots 就是 r 和 s， 因为我不知道它的 roots 是多少，我可以设它是 r s， 这没问题吧？假设它是 r s， 那我们就知道它的 factor 一定是 x 减 r 乘以 x 减去 s 等于0，它的 equation 一定是这样的，瑞卡对不对？对吧？这样我们举例子，那1和2你一定 factor 是 x 减1 x 减2嘛，对不对？负1和0一定是 x 乘以 x 加1嘛，比如这两个 roots 你一定是这样的 roots， 对不对？你要知道 factors，OK？所以呢，我们就说，如果一个 general equation general quadratic equation 它有两个 root， 那么就说明它的 equation 呢就长成这样。但这里有个问题啊，瑞卡，你看啊，你看这个底下的两个 factor 和顶上的这个 quadratic， 它们呢有一点不一样，哪里不一样？就是啊，如果你底下两个 factor x 乘以 x， 是不是只有一个 x squared？ 但是上面这个 general equation 有个 ax squared 呀，这个 a 怎么处理啊？对不对？那这个 a 如果是2，那么它们不就不一样了吗？对不对 ？OK 吗，瑞卡，明白吗？对吧？好，那你看啊，但是这里其实不影响，为什么？因为我可以给它乘一个 a， 比如说你看我给这里这个 factor 乘一个 a， 不影响，因为我这个 a 乘以 x 减 r 再乘以 x 减 s 等于0，依旧是我的 root 还是 r 和 s， 对不对？因为 a 不是0嘛 ，a 不可能是0，只有可能 x 减 r 等于0，那你就是一个答案是 r， 一个是 x 减 s 等于0，一个答案是 s。对吧？所以我可以乘这个 a， 反过来说呢，我给它除一个 a 也没问题。也就是说，这个 ax 方加 bx 加 c 等于0，我是不是可以两边除以 a 啊？这个没有问题，也不会影响到我这个 quadratic 的 solution， 对吧？So比如说 for example， 2x squared plus 4x minus 8 equals 0. To solve it, you can first divide by 2. X squared plus 2x minus 4 equals 0. Right? Okay, Aaron, that makes sense, right? Okay, any general equation you can divide by a number, basically to make the leading coefficient becomes 1. Okay, make it become 1, and then you don't have your solutions are still the same. The roots are still the same. 好，瑞克，你看，如果没问题的话，那么我们给它除一个 a， 除以 a 就是为了让它们 leading coefficient 是一样的。这样子呢，我们就有了这么一个叫做 x squared plus b over ax plus c over a。那么它等于啥呢？刚刚我们不是说，因为它的 roots 是 r 和 s， 它就一定等于 x 减 r 乘以 x 减 s， 对吧？因为两个 quadratic 它们的 roots 既然是一样的，说明它们两个 equation 就肯定是一样的呀，两个都等于0，对不对？而且都给到你同样的 root， 那说明它们俩一定是一样的嘛，对不对？这么是同一个 equation， 对吧？这同一个 equation 我们之前也见过了，比如说像今天这个例题，那5x squared 减去 59x 加上减12等于0，我们就可以让它等于什么？就等于这个 factor， 是不是就是 5x squared 加 59x 减12，它就等于它呀，对吧？一个 general quadratic 就可以变成一个 factor form， 就可以变成等于0，就可以找到 solution。只是把这个过程反过来做，明白吧 ？OK， 如果明白的话，那我们来看。那现在既然它们两个相等呢，我们就右边因为是括号嘛，我们就把这括号给打开。那先打开成这样，就是看你可以看这个计算过程就很简单，对吧 ？x 乘 x 是 x squared，负 r 乘以 x 是 minus rx，right？x times minus s minus sx，and then minus r minus s plus rs，right？OK，and then we combine like terms， 可以看没问题吧？你看这减 rx 减 sx 是不是可以 combine 一下？好，基本上就完事儿了。你看，得到这一步之后，现在 x square 是一模一样的。你看这一步很重要，对不对？如果我们一开始没有除以 a， 是不是这一步 x square 不一样就消不掉了，对吧？所以一开始一定要除以这个 a 啊，让它们的 leading coefficient 是一样的，我们就把它消掉。消完了之后呢，既然左边等于右边，那左右两边的 linear terms 是不是得完全一致啊？因为左边等于右边，那左边的 linear term 是不是一定要等于右边的 linear term 啊？注意，当你把 x square 消掉之后，其实左右两边都是什么？都是 linear equation。说白了 ，right? Okay, Aaron, make sense? If you eliminate x squared from both sides, then both sides have or just basic linear equations, right? It's just some number times x plus a number. So say that if your left hand side is 3x plus 7 equals, well, if you want to find another linear equation that equals to it, then the right hand side must be 3x plus 7 as well, right? That's the only way to make them equal. 没问题吧？你左右两边都是 linear equation， 那只能是一模一样嘛，你才能有个 equal sign， 不然你怎么能 equal 呢？对不对？你不可能做到 equal， 对吧 ？OK， 这说明两边的 linear terms 必须得是一样的。So that means AB over AX, the linear term of the left hand side, equals the linear term of the right hand side, right? 是不是等于这个负的 R 加 S 乘以 X 啊？两边的 linear term 是一样的。那是不是就可以把 x 消掉了？消完了之后，是不是得到了负的 r 加 s 等于 b over a？ 那我们把这个负号移过去 ，r 加 s 就是负的 b over a 啊，这就 prove 了嘛，叫做 sum of roots 等于 negative linear coefficient divided by the leading coefficient。OK， 然后呢，我们还可以 compare 它们两边的 constant term， 对吧 ？So constant term， 即 constants， 左边的 constant 是不是 c over a？and 右边的 constant 是不是 r 乘以 s 啊？那是不是它们直接得相等了 ？constant 必须得一样嘛？如果全部都一样，说白了你两边都 eliminate， 最后0等于0，两边就一样了。如果不一样，你最后不能 cancel out， 你两边肯定不一样，对不对 ？OK 吧？所以 constant 是一样的，那种 r times s 就是 c over a， 这个叫做两根之积的 product of roots equals what? Equals to the constant coefficient or the constant term divided by the leading coefficient. Okay, these three letters A, B, C are the three letters from the original equation. Okay, the original general quadratic equation from this ABC. Okay, C is a constant term, A is a leading coefficient, B is a linear coefficient. Okay, Rika, 你觉得明白吗 Good. Okay, Lily, Aaron, any question about this?
Why did you say if you want them to be equal, then this means that they have to be the same number for linear terms?
Well, if linear terms are not the same, say 3x equals, say 3x plus 7 equals to 2x minus 4. Are they always, maybe let's say plus 7. Okay, make that 7 equal. Then this equation is not always true, right? This is only true when x equals 0. If we want to make the left-hand side and the right-hand side always equal to each other, then 3x must be equal to 3x. If you have 3x equals 2x, then this equation is only true for a certain value of x, right? Not for all values of x. But we said that the two equations are the same. These two equations are exactly the same. So that means 3x must equal to 3x, right? If you have 3x equals 2x, you are solving this equation, there's only one value of x that can make this equation true. But we want for any value of x, these two are the same. Because, well, these two, well, the left-hand side and right-hand side, they're two same equations. Does that make sense?
So what we're trying to do is for any value of x, they have to be equal.
Yeah, because if you go back,
Because that's what the question says, yeah.
Yeah, because the original quadratic equation is equivalent to this what we call factored form, right? Equivalent to our two factors. They are exactly the same. So they are the same regardless of the value of x. Not only just for one value of x, but for all values of x. So for any value of x, they should be equal. They should be the same. So that's why you must match all the terms. Okay, you match the quadratic term. You also match the linear terms, and you match the constant terms. Okay, does that make sense? Yeah. Okay. Yeah. So this is our final claim, or you could say the final result. Yeah. And this is something worth remembering because in most math competitions, when we talk when if there were questions about quadratics, most of them are about this thing. Okay, because regular factoring, whatever, those are also covered in school curriculum, right? This is what we mainly use in math competition. So you guys must remember this, okay? And also back in China, we learned this in middle school as well. Okay, so this is known as the Vieta's theorem, although the book didn't really mention that because the Vieta's theorem applies to cubic functions, applies to quartic functions, applies to any polynomial functions of any degree. But this is Vieta's theorem in quadratic functions, okay? So this is known as the Vieta's theorem. Vieta's theorem. And of course, it's just a theorem came up with a guy called Vieta, right? 这个中文啊叫做韦达定理，好吧？韦达定理，因为他是这个人叫 Vieta，他发现的东西啊，叫韦达定理。韦达定理呢是不光只适用于这个二次方程的，它是适用于很多高次，包括3次、4次、5次、6次以及任何次的方程都有一个 theorem。OK， 但是我们现在先学个最基础的，以后我们会学难。OK，later on we will learn, we will study Vieta's theorem in polynomials of higher degrees, and actually, for AMC10 we need to study it. Okay, AMC10 there were basically every year there's at least one question about Vieta's theorem in in polynomials of higher degrees, like in 4th degree, in 5th degree, even in 8th degree. Okay, so we will learn about that. Yeah, a little bit in the future. Okay.
So does this mean that, like, school math is really behind? Like the math taught in school is it's very behind.
It's very fundamental. Yeah, compared to math competition. But say that you go to IB school learn about this as well in higher degrees as well. So it's sort of like a competent, math education. And in public schools, it's really, insufficient. Okay.
Yeah. Yeah, that's what I'm asking. Like, is public school math education like insufficient for university or something?
If you really want to understand what is going on in university, then I do believe public education is lacking. Okay, but for most of people, in my experience, 90% of the students in math classes don't really know what's going on. They are just mechanically remembering all the formulas and try to get the correct answers and just get a good grade, and that's it. Okay, so for them, well, it really depends on what goal you have, right? If you want to really understand what's going on and if you're interested in math at all, and then you want to understand that I believe competition is a better curriculum to understand those. Yeah. Okay. Anyway, we're just gonna use this in different questions, and that's it. Okay. So sum of roots negative b over a, product of roots is c over a, and let's look at some questions and try to practice it. Let's say that we do this. Okay. So let A and B denote the solutions of this equation. Find the value of a minus 1 times b minus 1. Now, first of all, I can tell you that we cannot find the factors of this. So meaning that for now, we are not able to find the solutions of this quadratic. Okay, don't use quadratic formula. And actually, we don't need to use one. Even if it is factorable, we don't need to use it. Why? Because the two solutions are A and B. And what are these? If you open up brackets, you're just going to have a bunch of A plus B or A times B. And you can just plug in the numbers and find the answer, right? Okay, does anyone want to try it? Everyone want to give a try?
Do we expand it first?
Yes, we expand it first. Very good. So it's A.
It's AB minus 2 plus no minus 2AB plus 1.
Minus 2AB. With AB minus what?
Oh, minus A minus B plus 1.
Yeah, minus A minus B plus 1, right? Okay. So what is AB in this case? AB are the two solutions, right? A times B is the product of solutions. The product of solutions is C over A, guys, right? What is C over A? C is negative 28. A is 18, right? Okay, Lily, Rika, make sense, Aaron? So here we know that, so before we expand this, let's write down our Vieta's theorem, okay? In this case, the two solutions are A and B. We don't know what they are, but we know their product and their sum, okay? Their product is, well, C over A. Plug in the numbers, okay? C is negative 28, A is 18. And of course, we can simplify, divided by 2, that's 14 over 9. Okay, makes sense? And then we apply the other part of the Vieta's theorem, that's A plus B, the sum of roots. And the sum of roots in this case is negative B over A. Again, you plug in the number, okay? So negative, B is 3, and A is 18, right? And canceling out, we have negative 1 over 6. Okay, does that make sense to you guys? Okay, then does that mean we can plug in the values here, right? Okay, so Aaron, do you want to carry on?
Negative 14 over 9 minus negative 1 over 6 plus 1.
Yes, good. So A times B is negative 14 over 9. And minus A minus B, just minus bracket A plus B, right? So minus negative 1 over 6. So minus bracket A plus B, minus 1 over 6, right? And then plus 1. And yeah, whatever the answer is the answer here. Okay, so Rika, Lily, any question? Anyone? Yeah, 不难吗？对吧，Rika？可以吧？ Okay, it's just a very fundamental preliminary application of the Vieta's theorem. Okay, so be sure to use this when never applicable, because this, in many circumstances, it saves a lot of time for you. Okay. Let's look at one more question from AMC 12. And this question is in AMC 10 as well. Okay. Actually, each year, about 10 to 13 questions are the same for 10 and 12. Okay, 10 and 12, they have at least half of the questions being the same. Please read the question and see if you guys have any ideas. A and B be the roots of this. Suppose that A plus 1 over B, B plus 1 over A are the roots for this. What is Q? Okay, I'm gonna copy down this.
Does this mean that the equation for x squared minus mx plus 2 equals 0 is x minus a x minus b equals 0 because a and b are the roots?
Yes. Yeah. But Aaron, that's to prove the Vieta's theorem, right? You don't have to do that. You can just apply the two things here. Okay. So the first thing we can do is that whenever you see something like this, A, B are the roots of an equation, just write down Vieta. Okay, so write down Vieta. So what is A plus B in this case? Anyone? Sum of roots of this equation equals this, right? Plug in the numbers. What do we have? Just plug in the numbers, okay? This is the equation x squared minus mx plus 2, right? It has two solutions, A and B. And we know that A plus B, that's the sum of roots, right? Sum of roots equals to
-3.
-3.
Okay.
Negative, yeah, negative. Okay. Okay, where did you get -3?
I don't know.
Oh, okay. Sum of roots equals to negative b over a, right? B is what? What is b in this case? This b is not this b. Okay, this b is this question. This b is Vieta's theorem. Okay, in the Vieta's theorem, the b refers to the linear coefficient of the quadratic. Okay, they are not the same b. Okay, let me write down this.
Negative m in this case.
Yeah, negative m, right? Okay, ax squared plus bx plus c equals 0. Now, for this general quadratic, it has two solutions, r and s, right? And r plus s is negative b over a. B is this b, the linear coefficient, and a is this a, the leading coefficient. And for r times s, or the product of the roots, c, this c over a, the c is a constant term in the original equation, and a is again the leading coefficient in the original equation. Okay, Lily, that makes sense to you? This is the Vieta's theorem, right? Okay, so when we apply it, here the equation is x squared minus x plus 2 equals 0, right? X squared minus mx plus 2 equals 0. It has two solutions, A and B. That's what the question says, okay? So that means A plus B is the sum of roots. Okay, regularly, Aaron, makes sense, right? And the sum of roots equals what? Equals to this, right? Negative linear coefficient over the leading coefficient. What is linear coefficient?
Is the answer m?
Yes, m. Right? Because the linear coefficient is negative m, right? So you put
So it's
negative
m over 1.
over 1. Yes. Okay, recalculate, see if that makes sense.
Where did the 1 come from?
A 1 is a leading coefficient.
Oh, okay.
There's nothing here. X squared, so leading coefficient is 1, right? So that's the 1 here. That's the A in this case. Lily, 明白吧? Yeah, the linear coefficient is negative m, right? Yeah. So if you wanna recite this formula, you can say the sum of roots is negative linear coefficient over the leading coefficient. Okay, the sum of roots is negative linear coefficient over leading coefficient. Okay, the product of roots is constant over leading coefficient. 好，瑞卡，你看有没有疑问？没问题吧？这是它的方程，对不对？这是它的二次方程 ，a 和 b 是它两个 solution， 所以 a 加 b 是什么 ？a 加 b 就是根据 Vieta 嘛，就是负的这个一次项系数，在这里是负 m over 什么 ？over 它 leading coefficient，在这里是1。OK, Lily， 这个也明白了哈。
I have a question.
Mm-hmm.
Yeah, so for the previous question, AB minus A minus B plus 1, how do we know which term corresponds to which term in the standard quadratic?
Which term it corresponds to the standard?
Does AB correspond to A or the x squared?
Oh, you mean here? Here?
Yeah, like you have to it has to correspond, right?
C is the constant term, right?
Yeah, yeah.
In coefficient, so you plug it in.
Okay.
Right. Yeah. So because they are using A and B, they really should be using R and T, R and S, so that
Oh, yeah. Oh, I see, I see. That's what confused me. Yeah.
yeah, that's yeah. So think about this. You can switch these to R and S, then that just becomes R times S, R plus S, right? And that becomes our formula. Okay, and this question, if you switch it to R and S, it'll be just R plus S. But don't get confused, because for Vieta's formula, it's not just A and B. It's the A and B are just coefficients, right? So let's write it down. A times B is C over A. C over A is the, maybe we just write down this constant over the leading coefficient, right? The leading coefficient, okay? So the plot of roots is constant over the leading coefficient. Maybe we should maybe paste it here, right? So the constant in this case is negative 28. The leading coefficient is 18. It has nothing to do with A and B. These two A and B are just the solutions. They're the solutions of the equations. Okay, so for A plus B, that's negative. B is the linear coefficient over A. A is, again, the leading coefficient. Okay, the leading coefficient. So that's what the sum of roots is. So the sum of roots, see, negative linear coefficient over the leading coefficient. So negative linear coefficient is 3, so we put 3 here, and leading coefficient is 18, we put 18 here. Does that make sense? So do you guys remember that in the first class of quadratic, I have repeatedly stressed that in this equation, we say ax squared is the quadratic term or the leading term, right? And a is the leading coefficient, right? Bx is a linear term, and b is a linear coefficient. C is the constant, right? I have repeatedly stressed the names of them. And the reason why I did that is to get you guys prepared for Vieta's theorem. Because of Vieta's theorem, you must remember the linear coefficient divided by the leading coefficient. You must know what they mean, rather than just remember B of A, because sometimes we see B of if there are other B and A's, you're gonna get confused. OK， 大家瑞很多还记得对吧？第一节课我就不停的在讲，是吧？说这个 A 就是 leading coefficient，ax squared 叫做 leading term， 对吧？或者叫 quadratic term，quadratic coefficient， 然后 linear term，linear coefficient， 然后 constant。在这里呢，你最好就是背这个，就是 sum of roots 就是 linear 除以 leading， 然后呢这个 product of roots 是 constant 除以 leading。最好的其实背的方法不是把它背下来，而是记住这个推理过程。这个推理过程一点都不难啊，因为就是把你的 ax squared 加 bx 加 c 先除以一个 a， 使得你的 leading coefficient 变成了1，变成1之后开括号直接 match 就可以了 ，match linear term match constant 就得到这个结果了。你自己再做几遍，呢，多做几道题，一下就背住了。这个式子还是很简单的，一点都不难啊，对吧 ？OK。All right, so yeah, so Lily, does that make sense to you now? A plus B? Okay, and then we can move on. So applying the Vieta's theorem, what about A times B in this case? A and B are the two roots, right? Okay, so A times B, this is the product of roots. Product of roots is constant over leading coefficient for this equation. What is the ratio of the constant and the leading coefficient in this question? 2, right? Good. 瑞卡利对不对？是不是 2 啊 ？constant 是2嘛，对吧 ？leading coefficient 是1，是不是2除以1就是2啊 ？part of roots 是不是2？或者我们说2除以1吧 ，2 over 1 which is 2 OK， 瑞卡怎么样 ？make sense 吗 ？make sense OK，Lily 呢 ？Hello Lily， make sense 吗？这两个懂了吗？懂了哈 OK，so what's next？ Now we have another quadratic. X squared minus px plus q equals 0, right? This is another quadratic. And this quadratic has two solutions. Has two roots. What are they? One is a plus 1 over b, and the other is b plus 1 over a, right? So the two roots are a plus 1 over b, and the other is b plus 1 over a. Okay? And then what's next? You're going to find the value of q. So how do we find the value of q here? What does these two roots have to do with this q? Now, as a reminder, the Vieta's theorem is literally just stating the relationship between the two roots of a quadratic and their coefficients, right? Or the constants. Okay, so q is the constant here, and you know the two roots, and they have a relationship. What is the relationship?瑞卡丽丽，你可以想一下，整个 Vieta's theorem 其实在说什么？就是在说一个二次方程的两个根和这个二次方程中间的 coefficient 之间的关系，对不对？对吧？是不是一个二次方程两个根，它们的和啊，它们的积，以及和二次方程这个里面的 a、b、c， 也就是二次方程的三个 coefficient 之间的关系啊，对吧 ？OK， 那这个题是不是在问这个？你看这个题它给了一个 quadratic， 又告诉你它有两个 roots， 然后呢，它问你它的 constant term 等于几？它的 constant term 是不是跟这两个 roots 有关系？什么关系呢？看 Vieta 什么关系？这是 constant 对不对？是不是用第二个呀 ？constant 跟这两个 root 什么关系 ？Anyone？
Inverse relationship.
Inverse. To be specific, just the product of roots equals constant divided by the leading coefficient, right?
Yeah.
Okay, so we can use that again in this question. Okay, so again, I'm just gonna maybe copy this over here. Okay. So we know that the constant over the leading coefficient in this question, it's just gonna be q over 1, which is q, right? Equals to what? Equals to the product of roots. What are the two roots here? These two, right? The two roots have been given. So in this question, this q just equals to the product of these two roots. Okay, so this q equals to the product of the first root and the second root. So you're gonna time them. Does that make sense? You use Vieta again for the second equation, right? 有没有瑞卡丽丽看有没有疑问？在第一个条件啊，你看这个题总共就两句话，对吧？第一句话说 x 方减 mx 加2等于0，有两个 root 是 a 和 b， 那么就直接可以套 Vieta。a 加 b 是谁 ？a 加 b 就是负的 linear coefficient 负 m over quadratic coefficient over leading coefficient， 就是 m， 对吧 ？a 加 b 等于 m。然后呢 ，a 乘 b 呢 ，product of roots 就是 constant， 也就是2 divided by leading coefficient， 所以还是2。所以我们的第一句话其实就告诉我们这个 ，This is what you can get, what you can translate, okay, from the first sentence, from the first condition. Okay, and here comes the second sentence. 在第二句话里面说什么 ？In the second sentence it says this equation， 对吧？这个式子 x 方减 px 加 q 有两个 roots， 是哪两个呢？一个是 a 加 b 分之一，一个是 b 加 a 分之一 ，right？ 对吧 ？OK， 那么他问你说 q 是多少 ？q 就是 constant，right？ So we apply the second part of the Vieta's theorem。因为我们知道这里 q 是 constant， 那你如果用 r 加 s， 它都没有 constant 里面，你用不了嘛，对不对 In other words, for the second sentence, for the second equation, if you apply the Vieta's theorem, the second part becomes, well, r times s, so the product two roots. 你看是不是两个 root 相乘啊？两个 root 相乘，它是不是就是 constant over leading coefficient， 这是 q 啊。Of course, you can do the sum of the two roots, right? But sum of the roots here doesn't really help us. 你看啊 ，the sum of two roots in this case is r plus s. It's the linear coefficient over the leading coefficient and a negative. So it's negative p over 1, which is p. Right? So p here is the sum of roots. But the question is only asking for q. So this is no use. It is not useful. Okay, so we're just gonna wipe it out. We only use the second part of the Vieta's theorem because it involves the constant in it. And we need to, well, get the value of the constant. Okay, Aaron, make sense? Aaron, right? Rika, Lily, make sense? Rika 你觉得明白吗？这里对吧？Lily 你觉得 make sense 吗？Lily 有没有什么疑问？我看不到你 Lily，有没有什么问题？一定要搞明白。就是 quadratic 它两个 root 相加就是 linear 除以 leading， 相乘呢就是 constant 除以 leading。这个 linear 除以 leading 这里有个负号啊，就用这个，对不对？因为这里它两个 root 是不是告诉你了？一个是 a 加 one over b， 一个是 b 加 one over a 啊？那你告诉你了，对不对？那它的 product roots 就它们俩相乘，是不是就是 constant 除以 leading 啊？是不是就是 q？ 所以你觉得 make sense 吗？对吧？就是用这个 Vieta's theorem。OK 吧 ？OK， 那没问题，我就继续了啊。So to get the value of q, of course, you need to expand the brackets, right? So q, you expand the brackets. Okay. Does anyone want to expand the bracket? How do we expand the brackets here? Anyone? A times b. 来嘛，来一个做一下，来。Brackets, expand the brackets, anyone? A times b, right? No, okay, I'm just gonna do it as well. So a times b is ab. So ab plus a times 1 over a gives you 1, right? Plus 1. 1 over b times b, another 1, right? And 1 over b times 1 over a, 1 over ab, right? The product of roots, and if you expand the brackets, you get this. Okay, Rika, Lily, Aaron, make sense? Right? And then we can just plug in, because from the first condition, from the first sentence, we got what? We got a times b is 2, right? You just plug in 2 plus 1 plus 1 plus 1 over 2. So 4 plus 1 over 2, 9 over 2. So q is 9 over 2. OK, Rika, 你看有没有疑问 ？Aaron， 你看整个过程是这样的啊。第一句话，他说 a 和 b 是这个 equation 的两个 root， 我们直接用 Vieta 写下来。因为像这种句子啊，这种 condition 一定就是用 Vieta， 一定就是用 Vieta。OK, Aaron, make sense? OK, this kind of condition always we use Vieta because it gives you two roots a and b, and it gives you an equation. Then automatically, immediately, we know the relationship between the roots and the coefficients in this equation. Okay, so we immediately employ Vieta's theorem. Okay, and then in the second sentence, in the second condition, we are given that this equation has two roots, and we need to find q. Q is constant, so in the Vieta's theorem, we use the second part of it. Constant divided by leading coefficient is q. Q divided by 1, right? In this case, leading coefficient is 1. So it's q. And that equals to what? That equals to the product of roots. So 1 times the other. And then, of course, we expand the brackets and we see that AB is 2. It's here. So magically, we we just gonna plug in with this. It's kind of magical, right? Amazing. So if you apply, you will see that throughout, we don't even know what A and B are. And it's impossible to know what A and B are because we have an unknown number M here. But even so, we can still find out the value of Q. And that's the power of Vieta. 对吧？是不是从头到尾我们都不知道 A 和 B 是几啊 ？M 是几也不知道，对吧 ？P 是几，其实你也找不到，但我们就是能找到 Q 是几，因为这个是用别的。前面有没有问题？没有问题的话，我们继续啊。休息一下吧，我感觉你们可能有点那个啥，有点累啊。So let's take a break, OK？ 我们到休息10分钟，我们到55开始，好吧？55 and then if you have time, you have energy, take some time to think about this again and try to do this again from an example problems of the book, OK？ Anyway， 好吧 ，All right， some practices, yeah, some practice. Let's do these two. Vieta, okay, so we start from, let's do some exercises more about Vieta. Now this shouldn't be hard, okay? So first, find the sum of solutions. Anyone? Does anyone remember the sum of solution? Negative, what? Negative B over A, right? Negative linear coefficient over the leading coefficient. Okay, so what is the answer? Rika, 来，我一个点人嘛，受不了了啊！Rika，来，sum of coefficient
直接算吗？
直接算啊，对，等多少？公式还记得住吗？记不住给你拉过来。现在先不用背。
能帮我拉过来吗？
啊，拉过来，好，
好
就这个，好吧？
，OK，让我算一下，等一下下。
对，其实就不麻烦，就背这个公式就好了。
哦，好。
这个公式放在这儿。Sum of 这个是 sum of solutions 对吧？
对。
第一题就是找 sum of solutions， 怎么做？
Sum of solutions。这个还是负三x 等于，
我直接 sum 等于不是 x 啊，因为 x 是一个 solution 对吧？你现在是 sum of solutions，是要把两个 solution 加起来。那我们直接
有两个 solution 啊，我算出来了。
就两个 solution， 但是你不用把每个 solution 算出来，你直接套咱们的 Vieta。
Sum of solution
哪个是第一个，是第二个？这两个公式嘛，
是
对不对？
负9%，
对吧？是不是负？
还有一个4/15，对吧？
对，是，但是我们不要找 solution 呢，直接套公式 ，Rika，好吧？它有两个 solution， 你可以把它找，再把它加起来。但是我们今天学的 Vieta's theorem 就是在告诉你 sum of solution 嘛，对不对？sum of solution 是什么？是不是负的 b 除以 a 啊？
对，负的 84啊。
对呀，b 就是84嘛，对不对 ？b 就是 linear coefficient 嘛，对不对？
那就是负的 84除以负的32吗？还是
对，负的32是 a 嘛，是 leading coefficient 嘛，对吧？每一个 coefficient 一定要带符号啊，所以是负的84除以前面呢负的32，套进去就可以了。OK， 我明白。这两个 example problem 我就不该做了，因为连这个都还没套明白，我不该做那个可能太难了。OK， 我们到时候再看看 example problem， 自己回来再想一下，好吧？到时候再说。我们先做简单的 ，OK， 简单的直接套就行了。OK， 这等于几啊？
正的2，不好意思，我看成了64，我以为是2。
OK，84除32直接除呗，对吧？
2点。
别除别 除一个4 21，底下除一个48，21%嘛，对吧？完事了。做完了，你看很简单吧？不需要去算出来再加起来，多麻烦呀！你要先算 solution 很麻烦，然后再加起来非常麻烦，麻烦死了。OK， 直接套我们的别的，一定要学会套别的，好吧？任何时候 sum of roots、part of roots 全部都套别的。OK， 没问题了吧？All right, so second question, Lily. Second question, product of roots. Okay, product of roots equals this, C over A. 来 Lily, plug in your numbers, please. Lily, hello, Lily. Lily, 来，我带你做，快开一下麦。Lily 干啥呢？来，Lily 对 ，product of roots， 我们这是 Vieta 对吧？要记住 Vieta，product 就是 C over A，C 就是 constant 嘛，记得吧 ？ax 方加 bx 加 c 嘛，对不对？C over A，那这你看这个第二题，那 C 是多少？就是这个式子里的 C 是多少
C over A, C is 500
是500，
negative 500。
对 ，negative 500一定要带符号 ，A 呢？
18。
对，完事了吗？不是做完了吗？你看不难吧？直接除一下，负的250除以9，that's the product of roots。OK， 会了吧？你这两道题啊，要找 sum or product of roots， 全部套别的 theorem 就完事了，不要去把 root 找出来再加再乘。OK 吗 ，Lily， 瑞卡？就是最简单的往里面套数字啊，没有问题吧？这个也不会了吧 ？OK。直接套公式啊，这就是公式，回去把这公式背下来，这是非常非常重要的公式。这个国内啊，就是初中会学的，这个就是中考、高考都要考的啊，这非常非常就是常见、非常非常有名的公式，好吧？OK， next question. All right, Aaron, sum of roots is known and the product of roots is known. Find the quadratic, find the roots. So let's find the quadratic first.
The sum of roots is -1, so and the product is 15 over 4.
Yeah. So you know the ratio between the linear coefficient and also the constant with the leading coefficient, right?
Yeah.
So what's your leading coefficient in this case? The leading coefficient could be any number, remember? It could be
Yeah.
1, because you can always time by a number, right?
Yeah.
So to make things to make matters easiest, what do you want your A to be?
1.
Yeah, 1, exactly. Good, okay. So recalculate, okay? So in this question, we can just set our leading coefficient to be 1. Because leading coefficient can be any number. You can always multiply by a number, right? So let A equals 1. And based on the sum of roots and product of roots, what is B? Sum of roots is -1. What is the formula for it?
Negative B over A.
Negative B over A. And since A is 1, so that means B equals what?
1.
1. Good. Okay, so recalculate makes sense? We set A to be 1 and just apply Vieta's theorem, okay? And then product. So the product of roots is -15 over 4, and it is C over A. And again, since A is 1, what is C?
Negative 15 over 4.
Yeah, just -15 over 4. And then what is our quadratic?
X
A
squared
x squared, good.
Plus, it should be
Yeah, bx.
so x
Yes,
plus x minus 15 over 4.
exactly. There we go. Not that hard, right? Okay, makes sense?
Uh-huh.
Yeah. Okay, so Riccardi, does that make sense? We first let a equals 1 based on Vieta. Just write down your Vieta and then find out the values of b and c, and then just plug in, because a, b, c here just mean ax squared plus bx plus c. So if you know what your a and b and c are, then just equal this, and yeah, and this is your quadratic. Doesn't. Okay, so in this question, we don't have to set a equals 1, okay? We don't have to do it. What is an alternative value for a? Anyone? Instead of setting a to be 1, what can we set a to be? Another easy case. Or
3.
3? Why do you want it to be 3?
Or 2.
Any reason why you want it to be 2? I'm gonna give
Because
you a
oh, I see.
see this?
Because you want them to be easier to be calculated.
Yeah, so look at the product here. The
Yeah.
product theorem A is what is the easiest? It's C over A, 15 over 4. So A is
4.
4, right? We said A to be 4. That's another easy way, right?
Yeah.
Yeah, so A is 4, not 3, not 2, okay? Because, well, it tells us to be 4. Okay, Ricky, does that make sense? In this question, some product, we just write our Vieta down. You can let A to be 1, that's pretty easy. Or, since we can observe this C over A is 15 over 4, so we can set A to be 4. That's another easy way. Okay, in this case, if you set A to be 4, basically you're just gonna copy this down. Do the same thing for B and C, okay? So what is B in this case, anyone? If A is 4, what is B?
4.
4. And what is C?
Negative 15.
Negative 15. Yes. Okay. And eventually our equation becomes what? Plug in numbers. A is 4. So 4x squared. Okay. B is 4 plus 4x. And C is negative 15. So minus 15 equals 0.
So are both equations equivalent? They're equivalent, right?
Yeah, you see this first equation times 4 is the second equation.
Okay.
And actually, you can set your A to be any number. If you set A to be 3, well, it just doesn't make things easier, right? But setting A to be 3, you can get your B and C, and you will see that the answer is just, well, the first equation times by 3. Okay, if you set A to be, say, negative 10, then solving for B and C will just give you an equation of the first equation times by negative 10. Okay, make sense? So that's why we said the leading coefficient could be any number. You can time it by 4, you can time it by negative 10, you can time it by any number. Okay, 1/2, 1/4, whatever. Make sense? OK， 瑞卡丽丽看这个题有没有问题啊？怎么样？如果你把 a 当成1，就这个式子 ，a 当成4就底下这个式子，你看这两个式子是一样的。第一个是乘4，不就底下这个式子吗？因为这个 leading coefficient 可以想是多少就是多少，因为它们是 equation，它们等于0嘛，等于0你就可以乘4就是4，乘以1/4，它就变1/4，乘以负10，它就变负10。那之所以设1简单，是因为我们两个 就是 Vieta 它都是 B over A、C over A，对吧？如果你把 A 当成1，不就直接是 B 和 C 吗？直接写方程就特别快，好吧？所以一般都是设1的。当然这道题呢，因为有分数的存在，你也可以设4，因为 C 除以 A， 这个是15 over 4，你可以把 A 设为4，C 就直接出来了嘛。然后再把 B 弄一下，B 就是4，也可以。这样的好处就是你有整数，因为无论如何呢，你在做 B 问的时候 ，find the roots， 假设你是设1的话，你是不是还是得乘4变成 B 问，变成这个样子，你才能 factor 啊，对吧 ？OK，so Aaron, the reason basically I think for this question because we have question B, so actually letting A to be 4 is the best. Because even if you let A to be 1, when you get this equation, if you want to find the roots, if you want to factor it out, you're still going to time by 4 to make everything integers and then factor it out, right? Yeah, so the second way is actually better for this question only because it has a question B. If it doesn't have question B, I will say A equals 1 is easiest. Yeah. Okay, so finding the roots, just factor it out, okay? How do we factor this? Just 4, just 1, just 2 and 2, 3 and 5, right? 2 and 2, 3 and 5. So 2, 2, 3, 5. This way gives you 10 and 6. So the difference is 4. And you want positive 4, so negative is here, like this, right? 10 minus 6 is 4. Okay, put your x back. So the two factors are 2x minus 3, 2x plus 5. 0. So the solutions are, the first one, 3 over 2. Second solution, negative 5 over 2. To confirm it, you see the sum of roots, negative 1, right? Right, the sum of roots is negative 1. And the product of roots, see, if you time them, negative 15 over 4. Correct? Okay? Marika 没问题吧？直接 factor out 你会发现，哎 ，sum of roots, product of roots 是不是跟我们的一样啊？也就是说，我们的 quadratic 找的是没问题的。这个就是根据 Vieta 呢，通过 roots 把你的 quadratic 找出来。实际上它有多少个 quadratic？有无数个 quadratic。但这些所有的 quadratic 其实是一样的，因为说白就是乘一个数除一个数的区别。因为它是等于0嘛，等于0的话，你可以乘除都不会影响到它。OK， 影响到 roots。Any question, Rika, Lily? 好 ，All right， 那我们就做下一题啊。我看挑一个。Wait, 10.4.4 is the same as the example problem, right? A plus 1, B plus 1. Okay, so I'm going to skip it. This is the same, right? 10.4.5 is the same as 10.4.3, right? You set A to be whatever, and then find your quadratic and factor it out. You will be able to find the roots. All right, so let's do 10.4.6. This is from AMC. Do some more problem solving about this. Our formula, Vieta's theorem is here. Okay. If m and n are the roots of this, so notice that the roots are exactly, well, the coefficients, the linear coefficient and the constant here. Okay, and he's just asking for the sum of m plus n. Anyone? Just apply the Vieta's theorem directly. Anyone? Aaron 今天挺好，做的挺认真的。这个 Rika 李快，你们两个答一下，你们这一天都没有动了。Rika 来，你一个，Lily 一个，好吧 ？Rika 你来 apply 第一个怎么做？
我看一下。
sum of roots 对吧？看一下 equation 是它 x squared plus mx plus n， 对不对？然后它的 root 是谁？它的 root 是不是就是 m and n？
对啊，
那我们直接 apply Vieta's formula，OK？、得到什么 ？Sum of roots m plus n 等于什么？来，
那么 sum of root 等于负的 b 是 m 除以 x，
x 什么 a 是啥
a 是1，
？a 是1对吧 ？Leading coefficient a 是
对，
是1，凡是你看不到 leading coefficient 是1，如果有负号就是负1，对吧？是不是直接得到负 m？
对，
对，没问题吧 ？OK，Lily，what about product of roots？ The two roots are m and n, right? So the product of roots is m
n over 1。
n over 1, yes, which is n. Good. Make sense?
Yeah.
Okay, so basically what do we have here? We just have m plus n equals to negative m, and m times n equals n, right? Very simple. So for the second equation, because n is not 0, so you can cancel it out. That means, well, m is 1. When m is 1, plug into the first equation, 1 plus n equals to negative 1, and it's going to be negative 2. Done. So in the end, m plus n is just negative 1.
Wait, why is m equal to 1?
Oh, because using the second part of Vieta's theorem, you said, you remember that m times n is the product of roots, right? And you said equals to n divided by 1, which is n, right? So m times n equals to n, and then we just cancel out the n, right? We divide by n, we divide both sides by n. So n canceled out, m equals 1.
Why can't it be other number?
Okay, so, okay, Lily, m times n equals n, right? What happens if we divide both sides by n? The left side we have m. What is n divided by n?
Oh,
1.
okay, never mind.
这
I
是刚
thought n divided by n was 0.
n
Yeah.
divided by 1不是 minus 嘛，对不对？我这说我们卡在这儿了，或者你可以这么想嘛 ，Lily，m 是一个数，这个数乘以 n 呢就是 n， 那哪个数乘以 n 还是 n？ 那只能1乘 n 还是 n， 对吧？你别的数乘 n 肯定就不再是 n 了嘛。
It's okay, my math is dying.
I know, I feel it. Yeah, so m is 1, and then just plug in here. And actually, you don't need to get the value of n, right? Because the question is just asking for m plus n. So m plus n is negative m. We know m is 1, so this is just negative 1, and negative 1 is the answer. You don't even need to get negative n, get a value of n, but getting it is pretty simple, whatever. OK? 没问题吧？对吧 ？Rick Lady， 对不对？注意这道题它只是找 m 加 n 嘛，所以 m 加 n 我们也知道是负的 m， 知道 m 是1之后直接带进去负1就是完了。你看这道题很简单啊，虽然是 AMC 的题，这道题真的就半分钟，只要你对 Vieta 够熟悉，一套结束了。当然 Lily 你要会这个解方程，好吧 ？Cancel out 嘛 ，OK？ 都 divided by n 啊。
Do they teach Vieta in school?
No, not at all.
And how to figure out like how to factor and all this? How do students know how to solve the problems?
Solve what problems?
Like problems regarding quadratics if they don't know Vieta's theorem.
They can use quadratic formula, right? Quadratic formula gives you the solutions of every quadratic equation. So they have quadratic formula. We haven't learned quadratic formula so far. Quadratic formula is in chapter 11.
Okay.
Yeah, but in school we learn chapter quadratic formula. So Vieta's theorem is basically strictly for math competition. You see, all the questions that require Vieta's theorem is kind of flexible. It's very flexible in thinking, right? So you can feel competition from it. Yeah, I think by now you guys should already see the difference between math competition problems and regular school problems, right? Not only do we learn more knowledge and more formulas and more theorems, but also the way to solve the problems is kind of, you know, flexible. It's kind of more difficult. It's kind of more convoluted than school questions. School questions are very straightforward, right? Okay, yeah. Okay, anyway, so yeah, so there's one more question here. Maybe you can have a look, because I want to go to 10.5 and try to wrap it up. Okay, wrap this entire wrap chapter 10 up. Okay. 10.5 is about extensions and applications of everything we have learned so far. So yeah, let's talk about a few questions we might see. So problem 10.26. Do you guys think this is a hard question?
No, because you can factor the numerator and it cancels out with the denominator.
Yes. Okay. So regularly you guys can give it a try. Basically, if you factor out the numerator, they cancel out with the denominator, so it actually becomes a linear equation. 对吧？这个第一题直接就 cancel out，直接就上面一 factor 加入 cancel out，要记住啊。OK， well, next thing we have this. Okay, so AMC 12 probably gonna have a look. Okay. So what values of k will make this equation have no solution? So solutionless, right? So the case here. How do we do this? Any idea?
We know that x cannot be 2 and x cannot be 6.
Mm-hmm.
And that's all I know.
Okay, good. So first we mentioned that we noticed that x cannot be either 2 or 6, right? And then, well, how do we solve for this, right? So basically, if there's no solution for x, probably if we solve for this and we just make solution become 2 and 6, and then that means there's no solution, right? Okay, so how do we solve for this? I think the first step is pretty easy. It's a fraction equals a fraction. What do we do?
Cross multiply.
Cross multiply, right, everyone? Right? So we first cross multiply equals to this. All right, and then what do we do next? The next step is also pretty intuitive. What do we do? Brackets.
Foil.
Yeah, of course we fold it out, right? We open up the brackets, we expand the brackets. So the left hand side we have x squared minus 7x plus 6. Now the right hand side has a k in it, so be sure you open it up right. Okay, so x times x is x squared, and then minus 2 times x minus 2x, x times minus k minus kx, and minus 2 minus k plus 2k. Pay special attention to this term, okay? The reason why we have kx instead of xk, the reason why I wrote k before x is that, well, k is a number, right? Here you must treat k as if it's just a number. So k is 3, k is 4, k is 5. Then, of course, you're going to write down minus 5x, minus 4x, minus 3x, minus 6x. So k is before x. K is a coefficient here. Does that make sense? Don't write xk. Okay, this is confusing to you. And also, if question requires showing work, then this is incorrect. Okay, k is the coefficient. K is a number. Okay, guys, make sense? Then we can just carry on and try to solve for this, right? So first, you see, we can cancel out x squared, right? And then how do we solve for x? Always remember k is a number, then you can solve it, okay? Because here, say that you change k into a number, say it's 4, and that means this is 2 times 4 is 8. this becomes a very easy linear equation, right? It's just that now we don't know what value is k is, okay? But k is a number. In essence, this is just a linear equation. So how do we solve for x? If you couldn't figure out, just replace k with any number. Okay, replace k with 1 or 2 or whatever. Okay, replace k with any number, and then you can think, how do we solve for this? And use the same step for k instead of 2. Nothing? Well, if k is 2, for example, then you have minus 2x, minus 2x. This is minus 4x. And basically, you bring it over here, or bring the negative 7x over here, right? You bring all the x terms together, you bring the numbers together, and you do a division, right? Yeah, so for k, we do the same thing. So, really, that makes sense? Okay, you do the same thing. Okay. Okay, let's say k is 2. Okay, let's say k is 2. And do the same, right? You have negative 7x plus 6 equals to negative 4x. You combine like terms plus 4. You move them together. This is 3x. 6 minus 4 is 2. And you divide it by 3. So 2 over 3. This is when k is 2, right? If k is 2. But k is k. But that doesn't change anything. You just do whatever you would have done if k is any other number, say k is 2. Okay, so now if k is just k, again, we bring all the x terms together to one side and bring all the numbers to the other side, right? So say that I'm going to keep 6 over here. Let me bring this to the other side. So it'd be 6 equals negative 2x minus kx. Okay, I'm just copy them. And then I'm gonna bring this negative 7x to the other side. So I'm gonna plus 7x, right? I'm gonna add 7x to both sides. So plus 7x. And then this 2k is a number. So this number, I'm gonna bring it to the left-hand side so that it goes with 6. So plus 2k, I'm gonna minus 2k, it becomes 6 minus 2k. So what I'm doing here is that subtracting 2k from both sides, and also I'm adding 7x to both sides. Right, make sense? This way I'm bringing all the x terms together and bring all the k's or the numbers together. Treat k as a number. Okay, treating k as a number is the trick here, okay? It's the technique here. And now we do the next. So here we can combine like terms, right? Here's negative 2x plus 7x, that's 5x. 5x minus kx, just 5 minus kx. Okay, if you have trouble doing this, maybe just consider common factoring. Okay, notice that x is the common factor, so take it out, and that will just become negative 2 minus k plus 7, so 5 minus k. Common factor, okay? If you have trouble combining like terms, and here you can use common factor. Common factor, I believe you guys are pretty familiar with it, right? Because combining like terms in its essence is common factor, right? 7x minus 5x. The reason it is 2x, one of the reasons you can explain this is through common factoring. X is a common factor, 7 minus 5, so that's why you get 2x, right? Combining like terms is getting the common factor. So here, if you have a k here and you don't understand what's going on, you get confused, just use common factoring. X is common factor, and the rest of them go together. Okay, on the left-hand side, we have 6 minus 2k. And eventually, if we want to solve for x, you divide by 5 minus k, right? So 6 minus 2k divided by 5 minus k. Okay, if you recall, this is what? This is solving x in terms of k, right? Solving x in terms of k. Any question? Okay, so we cross multiply, we treat k as if a number, okay, just like a number, combine like terms, we put numbers together, we do a division in the end. Why do we want to do this? Because as Aaron mentioned, we know that if x equals to 2 or 6, then there's no solution. Now we have solved x in terms of k, so this means that if we want the original equation to have no solution, we're just going to make this equals to 2 or 6, right? So we just say that if x, so think about this, if x equals to 2 or 6, there's no solution, right? No solution, and which is what we desire. So that means either 6 minus 2k, because we know that x is 6 minus 2k divided by 5 minus k. So if this equals to 2 or 6, then the corresponding k value is the value of k that will render the original equation no solution. Right? Okay, makes sense? Then we just need to solve for k. This is, well, just come by 5 minus k. This is something we have learned before. Okay, so we can solve for k, but here's just calculation, but before it, I think it's most important. 你看，我们再过一遍啊 ，recalculate， 看有没有明白啊？这道题问的说是 k 取什么值的时候，这个式子没有 solution， 对吧？那它怎么会没有 solution 呢？我们就要想，刚刚 Aaron 一下就想出来了，就是分母不能为0嘛，对不对？如果你这个式子解出来 x 是2，或者说 x 是6，那是不是说明这个式子就没有 solution 啊？因为这个式子里面 x 不能是2或者是6嘛，对不对？所以我们要解这个式子，怎么解呢？那分数等于分数肯定直接 cross multiply 之后呢，会有很多 k， 有 k 怎么办？我们说，因为 k 就是一个数啊，所以如果 k 是一个数，你看直接就解了，就是这是个linear function，非常简单嘛，对不对？如果 k 是一个数 x 减2 x 加5，这我们昨天都学过，特别的容易，对吧？只不过这里是有个 k， 那有个 k 怎么办呢？就把 k 当成一个数来做，怎么做呢？跟我们正常解方程一样 ，x 一边，数字一边。你别看6减2k 有字母，但它是个数字呀，因为 k 是个数啊 ，OK？ 所以数字一边带字母的 x 一边，然后呢，把这个 x combine like terms 嘛，这个合并同类项 ，OK？ 同时带 x term， 把 x 拿出来，直接做个 common factor， 对吧？把 x 作为公因数拿出来，对吧 ，Rika？ OK？ 把所有的系数相加嘛，所以-2减 k 加7是5减 k， 最后呢，把这5减 k 除过去，是不是 x 等于它？你别看 x 等于它很奇怪，但是 k 是个数啊，这里你可以把 k 换成任何数，可以换成1，可以换成2，可以换成3，可以换成4，那不是各种各样的 x 就出来了吗？对吧？但是我们需要 x 是几？这道题它希望我们没有 solution， 没有 solution， 什么时候没有 solution？ 我们说了嘛 ，x 不能是2或者6，对不对？所以为了使得它没有 solution， 我们只要让 x 是2或者6就可以，那就是找出来这个 k 值，6减2k 除以5减 k， 它等于2也行，它等于6也行，这两种情况都没有 solution， 对吧？都会让这道题没有 solution， 对吧？然后就分别解，把这个 k 解出来，两个答案就行了啊。那这一解方程就比较简单，对吧？那它等于2，这直接把5减 k 乘过去，又是 linear function， 直接就解出来了啊。我就不解了，对吧？你等于6也可以，直接乘过去把 k 一解就完事了。那么这两个对应的 k 值就会使得，也就是啥意思啊？我把它解一下，我怕你们没有明白啊。那你看我们放在这儿，这是一个，另外一个是6，对吧？我们迅速解这个解的也快，对吧 ？So 6 minus 2k equals to 2 times 5, so 10 minus 2k. And in this case, actually, there's no solution for k, you see? So no solution for k. No solution for k. In the second case, we have 6 minus 2k equals 30. minus 6k. So that will be 4k equals to 24, k equals 6. So what this means is that if k equals 6, okay, if k equals 6, this thing equals 6, right? What is this thing? This thing is x, remember? This is x, okay? So if k equals 6, x equals 6. The only solution for x is 6. And going back, we know that x cannot be 6. So there's no solution. To verify this, you can just, we know k is 6, so we can make k equals 6, okay? So let's verify it. It's here. Okay, so let's verify. Now, k equals 6, right? So we have x minus 1 over x minus 2 equals to x minus 6 over x minus 6. Okay, you see what happens? They just cancel, right? Well, actually, we don't know if they can cancel because we don't know if x is 6. If x is 6 is 0, you can't really cancel it. But whatever, okay, you cross multiply or cancel it is fine. It just gets to x minus 1 times this, x minus 2 times this, right? Just from here, you can see the solution. You don't have to open up brackets because this is a number times a number equals this number times the same number. Think about this. The same number times two different numbers, and they're still equal. What a surprise. This means that x minus 6 must be 0. Because only 0 has this property. Only 0 times different number can still be the same, right? We know that x minus 1 is different from x minus 2. Okay? And x minus 6 is the same as x minus 6. So if the same number, okay, x minus 6 times two different numbers and have the same product, then immediately we know that it's 0. Or you can open up brackets, but you'll get the same answer. 所以注意这个地方，你这里一 cross multiply 就可以看到它直接是0了，因为只有0有这个性质，0乘以两个不同的数才能相等，要不然你任何不是0的数，你乘以两个不同的数不可能相等的嘛，对不对 ？OK， 所以就想明白这个，它是0，那 x 减6是0， so if x minus 6 is 0, x is 6, you see it violates the denominator not being 0, so there's no solution. X cannot be equal to 6. Okay, or if you want, you can cancel it out. But cancel it out is not mathematically correct. Okay, because when you cancel out a fraction, you have to make sure the denominator is not 0. In this case, the denominator is actually 0, so you cannot cancel it out. Okay, but even if you cancel it out, you can still get this. Because if you cancel it out, you get x minus 1 over x minus 2 equals 1. You time by x minus 2, you will see that you get negative 1 equals negative 2. Again, there's no solution for this because they don't equal. Because they don't actually equal. So x minus 1 couldn't be equal to x minus 2. 这个应该 make sense 吧？你任何一个数不可能减了1之后还等于它减2，因为 by definition 它减2就会比减1小1嘛，它们怎么可能相等呢？对不对？但是这个不好啊，这个做法不对。为什么不对？因为从一开始你就不能 cancel out。当你 cancel out 的时候，你一定要 make sure 分母不是0。你怎么知道分母不是0？你不知道，对不对？所以不能这么做。这里就直接 cross multiply 就可以了。cross multiply 就看到等于0 ，and then x equals 6, but it cannot equal to 6, so no solution. That means for k equals 6, there's no solution for x. 就是把前面这边搞明白啊。Solve x in terms of k using the same method as if k is a number, and then let's just make it equal to make x, or the expression of x in terms of k, make it equal to some illicit values of k of x, so that there's no solution for x. Okay. Okay. That's all for today. For homework, maybe just continue to do our exercises. Try to finish chapter 10. There were a few, just one more type of question. This one is fine. This one you don't have to do it. We're just gonna talk about nested radicals next time. And yeah, okay. And that's basically it. Do our homework, review exercises and stuff. And if you have time, you can do challenge. See you guys next time. Okay.
拜拜。
Bye.
老师，拜拜。
Bye.